Find the horizontal asymptotes of f of x equals the hyperbolic tangent of x. With any hyperbolic function, we will need to rewrite it so that we can work with the definition of the exponential function. But first, f of x equals tangent hyperbolic of x, which is the hyperbolic sine of x over the hyperbolic cosine of x. But the hyperbolic sine of x is e to the x minus e to the negative x over 2, and the hyperbolic cosine of x is e to the x plus e to the negative x over 2. So the 2 and the 2 canceled out. We end up with e to the x minus e to the negative x over e to the x plus e to the negative x. To find the horizontal asymptote, we need to look at the end behavior, meaning we need to find the limit at x go to infinity or negative infinity. Taking the limit at x go to infinity of the function f of x is the same as taking the limit of e to the x plus e to the negative x over e to the x plus e to the negative x. Although this is not a polynomial function, we can use the same trick by dividing by both numerator and the denominator by the highest power in the denominator. And so we would divide it by e to the x to every single term. What we are doing is we multiply 1 over e to the x in the numerator and 1 over e to the x in the denominator. This is known as the well-chosen one, so we're not changing the function. Multiplying this well-chosen one is a trick that will allow us to evaluate the limit easily. The limit at x go to positive infinity of 1 plus e to the minus 2x over 1 plus e to the minus 2x. E to the negative x over e to the x is e to the negative x minus x, which is e to the negative 2x. To be clear where the term e to the negative x go, we take the limit at x go to infinity of 1 plus, and we rewrite this as 1 over e to the 2x. The same in the denominator, 1 plus 1 over e to the 2x. Keep in mind that at x go to infinity, the denominator e to the 2x gets very large, and so the term would go to 0. Similarly, 1 over e to the 2x go to 0 as well, and so this limit is simply 1 over 1 or 1. As x go to infinity, the function is approaching 1. This means we have a horizontal asymptote, y equals 1. But just to be safe, we are going to check the limit at x go to negative infinity as well. The limit at x go to negative infinity of the function is the limit of x go to negative infinity of e to the x minus e to the negative x over e to the x plus e to the negative x. But unlike the previous procedure, this time we would multiply the well-chosen one, which is 1 over e to the negative x, 1 over e to the negative x, and that is because as x go to negative infinity, e to the x actually go to 0, but e to the negative x go to infinity. We can see this from the graph of e to the x and the graph of e to the negative x. At x go to negative infinity, the graph of e to the x stay close to 0, but the graph of e to the negative x go to infinity. What we want to do here is to divide by the dominating expression. At x go to negative infinity, e to the negative x would dominate e to the x. And so we end up with the limit at x go to negative infinity of e to the x times 1 over e to the negative x is e to the x over e to the negative x minus e to the negative x times 1 over e to the negative x is 1. Similarly, in the denominator, we have e to the x over e to the minus x and then plus 1. We still need to evaluate this limit, but we will do this by rewriting e. At x go to negative infinity, this is e to the positive 2x minus 1, because e to the x over e to the negative x this time, it is e to the x minus negative x, which is e to the 2x. But x go to negative infinity though. At x go to negative infinity, the exponent is a negative number, and this negative number is very large. E raised to a very large negative number is close to 0. And so the numerator is 0 minus 1, and the denominator is 0 plus 1, giving us negative 1. As x go to negative infinity, the function approach negative 1. So we have another horizontal asymptote y equals negative 1. In summary, the function f of x equals hyperbolic tangent of x has two horizontal asymptotes. One is y equals 1 and the other is y equals negative 1.